Standard history books often treat human thought as a sequence of upgrades. The narrative suggests that as we grew more sophisticated, we systematically traded our early frameworks for superior models of reality. This is the traditional ladder of progress. It maps a climb from myth through religion and philosophy until we finally arrive at science, ascending from falsehood to objective truth. This model represents a fundamental misunderstanding of how we actually process knowledge. The false to true equation collapses because these traditions are not competing to solve the same problems. They operate under different rules to answer different questions. Cognition functions more like a coordinate system than a ladder. We must view these disciplines as overlapping volumes within a multidimensional space. Mapping human knowledge requires us to abandon the linear progression and acknowledge that different modes of thought coexist as distinct regions in a cognitive continuum. The latter model fails to explain the reality of the scientific mind. If new paradigms simply deleted old ones, a physicist would lose the ability to understand religious symbolism or philosophical logic the moment they learned calculus. Instead, the history of science is filled with architects who operated across multiple frameworks. Einstein used rigorous mathematical modeling while simultaneously navigating deep philosophical epistemology. When Niels Bohr and the founders of quantum mechanics hit the limits of observation, they engaged in metaphysical questioning to interpret the reality they measured. Scientific reasoning expands our cognitive repertoire. It doesn't replace our capacity for mythic or intuitive thought. By treating existence as a mathematical vector, we can precisely map how these frameworks overlap, diverge, or oppose one another without breaking. We can define any epistemic system, any way of knowing, by its coordinates across 6 specific variables. This allows us to calculate exactly where a discipline sits in relation to others. The foundation rests on sensory grounding, represented by S, which tracks how closely a claim relies on direct observation. Its counterpart is abstraction, or A, measuring how far the concept moves away from immediate perception. To these, we add C for conceptual integration and R for external reality constraint. These track how well the ideas fit together internally and how strictly the physical world can prove them wrong. Finally, we add B for boundary awareness, the recognition of a theory's limits, and L for the reasoning regime, the specific logic applied to the problem. We often assume science is simply more integrated than older systems, but a complex theology is often vastly more conceptually integrated than many branches of empirical science. When we plot these clouds, theology spikes toward maximum integration. Science, however, is defined by its extreme scores on reality constraint and boundary awareness. The unique signature of science is the specific pairing of high abstraction with rigorous external validation. Let's focus on the L variable, the reasoning regime. Logic is a multidimensional toolset rather than a single instrument. Choosing the right logic requires us to look at the texture of the domain we are studying. Some parts of reality are fluid and ambiguous, while others are sharply constrained. As the texture shifts from fluid to constrained, the appropriate logic moves from fuzzy to statistical, then deterministic, and finally to pure formal logic. Error occurs when we apply the wrong logical texture to a domain. Forcing rigid deterministic logic onto highly contingent historical events leads to a total misunderstanding of the system. A messy biological cell in motion is a probabilistic domain. It cannot be accurately modeled with strictly deterministic logic. It requires a statistical regime to account for its noise and uncertainty. Internal coherence does not guarantee external truth. A metaphysical system can be perfectly logical while its premises remain entirely absent from the physical world. Logic serves as a valid inference tool, but applying the wrong logical texture to a domain results in a categorical error. When we ask if something exists, the word conceals a wide range of different operations. We must break this monolithic concept apart. We can measure any existence claim across 8 specific dimensions. This vector allows us to distinguish between being and being perceived. We start with the physical cluster, S for sensory accessibility. Can we see it? EP for physical interaction. Can it push something else? And EM for mental representability. Can we imagine it? Next is the abstract cluster, EC for conceptual coherence. Does the idea make sense? And EF for formal specification. Can it be defined in mathematics? Finally, the validation cluster. EO tracks observational support, ER tracks reproducibility, and EB establishes the boundary range where the claim is valid. This breakdown shows how something can score a maximum value on the mental or conceptual axes while registering a 0 on the physical axis. Conflicting ideas about reality often stem from conflating representational existence with external physical existence. To see this model in action, we can apply the existence vector to an imagined island, a philosophical concept, and a subatomic particle. An imagined island has a high value for mental representatability. Your brain creates the sensory details, but it registers 0 for physical interaction. It has a real representational status, but no geographical reality. The concept of justice spikes on the axis of conceptual coherence. It is a robust abstraction that guides human behavior, yet it is invisible to the senses and registers a 0 for sensory accessibility. A theoretical subatomic particle requires maximum formal and mathematical specification. But the claim is a pulse. It remains purely formal until observational support confirms it as physical reality. This was the state of quantum mechanics in its infancy. Heisenberg and others developed the formal math, but they had to wait for physical experiments to provide the reality constraints. In every case, the representation of an entity is not evidence of its external existence. Reliability depends on the domain reasoning correspondence principle. To be accurate, our reasoning regime must match the organizational texture and boundaries of the domain we are investigating. Physical events convert through sensory and neural processing into the experienced world. This pipeline is interrupted by critical boundaries, where variables change. Crossing them requires a logic shift. Deterministic mechanics describing a photon cannot describe the subjective experience of light. The brain transforms raw physical input into an emergent representational world. This is a transition from physical organization to experiential organization. Neuroscience establishes that the mental world is generated within the physical world, but it remains a distinct regime with its own rules. While reality may be continuous, the mathematics and reasoning we use to describe it must shift whenever we cross these critical boundaries. The ultimate paradox is that the continuity of reality does not entail the continuity of our models. We cannot use a single descriptive framework to explain everything. Newton's mechanics provided an incredibly successful model for centuries, but it hit a scale boundary where it broke down and required the entirely different regime of relativity. Human history shows a massive expansion of our cognitive repertoire, where older modes of thought remain active alongside newer, more constrained ones. Because we can think mythically, philosophically, and scientifically all at once, a mature epistemology requires constant boundary detection. The primary intellectual skill in this framework is meta-reasoning, the capacity to identify exactly which reasoning regime applies to the specific conceptual space you currently occupy. By mapping knowledge as a multidimensional coordinate system, we can move past a false war between disciplines and coordinate the precise geometry of human understanding.